These are the instructions for assembling the logic probe for ELTN 132. And I wanted to start with a picture of the printed circuit board that you're going to be soldering up. If you haven't soldered before, it's not too difficult, and I have posted a couple instructional videos on this with the Vastar soldering iron and another good video on soldering technique. But I'll show you a couple solder connections as we go through this. The first thing you want to do is print out or get a copy on the screen of the bill of materials and also the assembly print. The main point here is to make sure that you've got everything that you need. You have all the parts. So I would check it, go through and make sure you have all the parts, all the components, all the resistors. And once you get those set out and make sure you have those, we'll start with the resistors. So here's the bill of materials for the probe. And what I'm going to do is suggest that you start with the resistors. They're the lowest components on the board. And also, they're all the ones that are going to be soldered on the top of the board. There are going to be a few components that we solder on the back side, so it's important that you watch this whole video. But I'm going to start with resistors 1, 2, and 6. And that may seem a little out of sequence, but they're all the same value. So I'm going to solder these and work my way down. So I'm going to find those first three resistors and place them on the board. So here are the three 8.2K resistors, and that's going to be R, 1, 2, and 6. The spacing on these is not super critical. What I found is that if you just give them a gentle bend at the ends like this, that will usually give you enough space to put them in the board. So I'm going to locate those on the circuit board and place those in. Now, a couple things to note here. Make sure that the resistors are pressed down flat on the circuit board. You want to make sure you have no what they call skyscrapers where they're like sticking up, for example, like that. That's not very professional. So what I usually do is just take those and bend the leads back at a small angle, maybe, I don't know, 30 degrees, something like that, and that'll hold them in place. And I also double check, again, on the bill of materials that I've got the right resistors in the right place. It's one of these situations of measure twice, cut once. If you solder the part in the wrong location, it's a pain to unsolder it. It's so much easier to take a little bit of time and double check it. So double check each of those as you're going along. Okay, so I've got those in there, and we'll go ahead and solder those up now. Okay, so I got the soldering iron hot enough here to go ahead and solder. So what I typically do is I'll put a little bit of solder on the tip of the iron. It helps the heat transfer. I'm going to place it on the corner of the pad there, heat the connection, and apply the solder. I'm going to go ahead and solder. Now, I wouldn't put all the resistors on. They kind of get in the way. You can put a few on at a time. I'll go ahead and solder these other ones here real quick. Again, you want to avoid, you don't want to touch solder and then dab it onto the connection. That's not going to work at all. The flux will burn off. So we're going to keep heating the connections here. And I'm kind of wiping off or cleaning off the tip of the iron between each of these connections. Okay. And we'll take a look at these in a little bit more close-up detail to see how they look. We got to check with our supervisor for a moment here. How are we doing? I don't think she's too interested. Okay, let's take a close-up look at these connections. Okay, so those have a nice fillet look to them, that kind of conical shape, which is good. The pad is completely covered, and it's not a ball. There isn't too much solder on there, so those connections look pretty good. That one might need to be cleaned up a little bit, but overall they look fine. And the resistors also are nice and flat to the board. That's the way you want them to look. It's okay if a little bit of solder comes up over through the top there. That's fine. And it's not necessary because resistors don't have polarity, but I think it makes it easier to read the value if you always put the green, or the green band, the gold band to the right there. So we got those three soldered in place, and we'll clip the leads. So I'm going to use a pair of dikes here. And I kind of keep my finger over the tip of the lead to keep it from flying off and poking out the eye of my cat or flying across the room. And we'll just go ahead and clip those other leads. You don't want to push it all the way flat to the board. You can give it a little bit of space kind of to the top of the cone at the connection where it's soldered. Okay, so when that's done, that's what the soldered connection should look like. And as I'm going through this, I'm going to just kind of check off each of the components as I go through this whole process. If it's been a while since you've looked at resistor color codes, it might be helpful for you to write those out, just so you make sure that you don't have the wrong part soldered in there. But I'm going to go ahead and solder in the rest of the resistors that way. One point that's very important on this particular circuit board is that there are 3 resistors. The bands look almost exactly the same color, so watch out for these. They're 33 ohms are orange black, the top 2. The bottom one is orange brown. And if you switch these values, the probe is not going to work properly. So if you're not certain that it's the right value, just measure it with an ohm meter or the DMM. But otherwise, just see if you can identify it for sure. The brown is definitely lighter color. It's a little hard to see in this video segment. Another potential gotcha is the 1 meg and 10 meg resistors. So the 10 meg is brown, black, blue. The other ones are brown, black, green. So again, keep your eye out for that. Make sure you don't mix those up. Okay, so I've been marking these off as I'm going here. Got all the resistors soldered up. We'll take a look at what the board looks like here. It's a little close. But you can see all the resistors are soldered in place. The next thing I'm going to do is solder these little tiny diodes. These are, let's see what they are, D2 and D3. They're very small glass diodes. You can actually, if you look very carefully, you can actually see there's a part number on them, 1N4148. And those are going to be soldered next on the board, bending the leads, doing it basically the same way we did the resistor. Those are D2 and D3. Now you notice on these that the leads are spaced a little further apart. So when you're bending the wires, make sure you leave enough space. And also, the other thing that's very critical is that that little black band on the top there that you can see on the left side has to line up with the white band on the silk screen there. So make sure that's lined up properly before those are soldered in place. Again, checking it twice before soldering it is going to save you a lot of grief if it's soldered incorrectly. So I'll place that other diode in there. If I can get it in. There we go. Snap that in place, and I'll go ahead and solder those in. Actually, I'll go ahead and do the other diode too. We might as well do that real quick here. So this diode is a power diode. I think it's a 1N4004, 1N4001. I think 1N4001 in this case. And it's going to go over here. And again, I'm going to give the leads a little bit more space when I do the bend on them. And again, I'm going to line up that white band with the silver band on the diode to make sure that they're correct, that they're lined up correctly. You'll notice that those leads are a little bit fatter than the leads on the other one. Okay, got the diode soldered in. Next I'm going to solder C1. That's this little yellow 1 nanofarad, which is 0.001 microfarad. I'm going to slide that in there and it pops in just nicely. I'm going to bend the leads there and solder it in place. We'll get the transistors next. Look very carefully at the transistors. You can see the part number printed on there. This is a 3904, which is Q2. And the top lead is bent up a little bit there. So to solder that in place, I'm going to bend the leads a little bit. And I'm going to go ahead and place that part inside there. And I'm going to push it down until it's fairly flat. About like that. I think there's plenty of clearance in the enclosure for that, so that shouldn't be a problem. But again, make sure that you're using the 3904 there. See if we can zoom in and see that part number a little bit. There we go, we can see it. And the 3906 is going to be the one that's located over here on this side. So again, you want to look at that part number carefully. Make sure we got the right part. And it's a little hard to see, but that's a 3906. And again, I'll bend that middle lead up a hair and slide it in, making sure that the flat side of the package of the device lines up with the flat silk screen location there, like that. And we'll go ahead and solder those in. So I've soldered those in. I'm going to clip the leads here. Just to kind of give you a view of what the soldering iron or the circuit board looks like on the bottom side. At this point, you might want to stop and just check and make sure that all the connections look good. That kind of goo that's still left there is rosin, the flux, and that's okay. It's not going to cause any problems. If we had some isopropyl alcohol, we could clean that off. We're not going to worry about that. But just check your connections and make sure everything looks okay. This is not probably the best example of soldering, but each pad is covered and it's not a big round ball and nothing's shorting out adjacently to any of the other connections on there. So those solder connections look pretty good. Next we're going to solder C2. That's this capacitor right here. It's a little hard to see, but there's a tiny little plus sign there, polarity symbol, and that's also the longer lead on the package. So the negative side is that shorter lead, and it has that little minus sign there. The positive lead is longer. Now, because this part sticks up so high, we need to bend it. So I'm going to basically bend this part. Let's kind of see it when I plug it in here. And again, making sure the positive lead is up on the top there. We're going to fold it over like that. The board is actually designed this way. I'm going to show you a little trick here that I sometimes use. It'd be a little hard to hold that in place, so I'm going to actually solder one of the leads on the top. May seem a little strange. And then push it down. But that'll make it a little easier when I solder the back side here. I'll solder the pad that isn't filled and put a little bit of solder back on there. So that's the capacitor. And we got one more component that we're going to put on the top side. That's the integrated circuit, that LM339. Now you'll notice on a lot of these IC packages that the leads are kind of bent out at an angle. That's for automatic robotic systems that insert the parts in robotically. So what you want to do is basically just bend the leads flat. I put it down on like a surface, a flat surface of some kind, like a table or whatever. And I'm going to bend these leads a little bit, very carefully, like that. So now that the leads are basically parallel, mine are in a little bit there, but it's pretty close. But you want to get it more parallel to the package, otherwise it's a little hard to put in. So we're going to get our board here again. We want to make sure that the notch on the left right there is going to line up with the notch on the package itself, which is right there. That's very important. And if everything is lined up properly, the text on the device should line up with the text on the silk screen also. So I'm going to go ahead and pop that guy in there, like that. Now this is a little tricky. I'm going to hold it with one side, flip it over, and bend these leads out just a little bit to hold it in place on all four corners. Not too much. You don't want to bend it flat. Sometimes people also will use tape to hold a part down. That works fine. Or you can also use that little trick that I used of soldering it on the top to hold it in place. Okay, so that's soldered in place. It looks okay. The flux is a little messy. You'll notice there's a little solder ball right there. So when you're done, you always want to kind of check and make sure that everything is kind of cleaned off. You can use like a brush or something, toothbrush, to clean that off. Okay, the last components, which is this little switch and the LEDs, we're going to actually solder on the bottom of this board, which sounds a little weird, but that's the way that it's going to be packaged. So here's the switch. And I'm going to go ahead and plug that in. And I'm going to actually put a little bit of solder on the side here on the top. It's actually the bottom of the board. I'm going to put a little bit of solder there to hold that in place. Those metal tabs on the side are basically to keep it in place so it doesn't move around because the pins are so small. You don't have to put a lot of solder in there. But once that's in place now, I can flip it over and I can go ahead and solder the pins on there. And these pins are probably the smallest thing you'll be soldering on this part or on the circuit board. So try to be careful and make sure. I'm just kind of going with the very tip of the iron there and soldering all those pins. And I can kind of put a little bit more solder on these pads that were holding the tabs in place. Okay, so if we take a look at that close up, That looks pretty good there. Okay, now the LEDs also need to be soldered onto the back side. But what's important is keeping track of where the flat side is. So on any given LED, there's a flat side. A little hard to see here probably. There, you can see it there on the left side. And that's going to be typically the shorter lead. So the shorter lead is the negative lead. The longer lead is the positive lead. So when we're soldering these LEDs in place, okay, first of all, we're going to solder them on the bottom. The second thing we're going to do, though, is we want to make sure that the flat on the LED itself is going to line up with that flat line there. So that's going to be the short lead is going to solder on that side. So I'm going to literally just flip it over like this, put the LED in, and for these we want to leave just a little bit of space. And the trick for this that I found is that if I'm going to bend these leads out here like that, and kind of let it dangle just a little bit. And I'm going to solder one of the pads on here. And I'm going to take a look. Now that's sticking out a little too far. And the reason why this is important is it's actually going to go into the enclosure and kind of pop out a little bit. So I'm going to push down, or I'm going to heat this up a little bit and push down on the LED. So it's sticking out just a little bit like that, a little bit off the edge. Once that's done, I can solder the other connection there. Now for the LEDs, what's interesting is the color that was chosen. They used red for a high and green for a low. And I found that so counterintuitive to me. I think of a 1 as being like a positive thing. And so I actually switched those, but it's kind of up to you. If you like the idea of red being a 1, then you could solder in the LED there. But if you don't, if you want green indicating a 1, then you want to flip those two. So you're going to solder those next two LEDs in, making sure the orientation is correct. Again, that short wire is the one that's going to go into the side on the right there. That's going to be the short lead. So I'll solder those in. Okay, I'm going to solder that one and that one. And again, once that's, we're going to kind of see what the length is. Ooh, those are really tall. So I'm going to reheat that a little bit. Try not to melt the iPhone here. I'm going to heat that up a little bit and push it back. And the red one can come down a little bit further. Let's take a look at that. That's pretty close. It's not super critical. It's just that if they're lined up like that, then the LEDs will kind of pop up a little bit out of the surface of the box. Okay, then I'm going to go ahead and finish soldering those. That one and that one. And clip the leads, and then we're almost done with the board. And we'll take a break there for a second, then I'm going to come back and finish it up. So again, the important thing is the components that are going to stay on the bottom of the board are the switch and the LEDs. Okay, the next step we're going to do is solder this little knitting needle, which is our probe, onto the probe itself, that pad, and use a wire to secure it. So I'm going to put a little bit of solder on here to kind of what's called wet that surface a little bit. So I use the alligator clip on the helping hand to hold the tip of the needle, and I'm using the lid from the little spring, the cleaner from the soldering iron to hold that in place. So let's see if I can solder this here. I'll zoom in a little bit. Because it's kind of a big surface area, you've got to get enough solder on there to flow all the way over the tip of the needle. So once that's done, now what I'm going to do is take an extra, I'm just going to grab a little scrap piece of wire that happened to be from one of the other resistors, bend it around in a hoop, and I'm going to place it on the end there and help secure that in place. Now it's held there in place well enough I don't have to re-clip it, but I'm going to go ahead and re-solder this solder the pads, and reheat the connection there. Now if you heat it too much, you'll reheat the point where it's soldered here. But at this point it looks fairly straight. It looks pretty even, parallel to the board, which is what we're looking for. If you need to adjust it a little bit, you can bend it a little bit. But you want to make sure that it's well soldered on the both ends. Now before we go much further, we want to check and make sure everything looks lined up on the enclosure we're using. The way these work is that you can just kind of pry the sides off. Kind of a cool design. And we're left with this little box. And if we carefully slide the needle, knitting needle into there, if everything is correct. Okay, so I was able to get it in the enclosure, but I noticed that on that end of the board that the hole for the needle is a little high, and it's lifting the whole board off. So what I'm going to do here, kind of cheat a little bit, I'm going to literally heat that needle and push down on it a little bit. You want to be careful that you don't end up melting the box. I should be able to get that hot enough that it'll actually melt the plastic a little bit. I'll be able to push down. We'll see how that works. Okay, that worked pretty well. So some of these holes, the other thing, if you got something, a drill or something that you can open up the hole with, that would work too. But now we got the board mounted in there, and we're going to see if we can solder the last wires on here for the clip leads and then test it. So you want to go ahead and take these alligator leads that we have and strip the ends, maybe about 1/8 of an inch. And I'm going to apply a little bit of solder here to the leads, just a little bit, and that'll help it stick to the PCB. Got to be careful when putting those, if you use helping hands, that you don't crimp on the insulation too much. And I'm going to solder these again from the top, which sounds a little weird, but if I can put the black lead there, the red lead there, now it might work better to solder them from the bottom. But if you solder this in place, and then what we want to do is put some glue on here to prevent this. I'm going to put some epoxy all around the wires here so that they don't end up getting pulled out when we use the probe. Okay, so I put a big glob of glue there, epoxy, and the main point there is that we don't want those wires to end up breaking off at that connection point. There's a little notch at the end of the box that allows the wires to go through. Okay, so now that's all finished, and we can test it out. Okay, I almost forgot the little screws that go in here. So there are 4 screws that go in the 4 holes, and I'll go ahead and screw those in. I found the screws are a little undersized, it looks like, on this side, so if you need to put a little bit of glue in there to hold it in place, that's fine. Or you can tape it down if you need to.